Welcome to the Pottorff CFD overview. So we're going to walk through an overview of the Pottorff radiation damper line and just generic overview of radiation dampers in general. So my name is Daniel Benton. I'm the Western Regional Sales Manager for Pottorff. And we also have Tom Ruggieri, who's the Eastern Regional Sales Manager. He's going to help out with this presentation as we run through radiation dampers.
Yeah, just a little bit of a backstory of radiation dampers. As many of you know, Pottorff is approximately 90-year-old company and has its roots in Southern California. And they started out as kind of a jobber shop doing decorative grills and metal ornate work. And they also represented a few grill and register companies that their contractors were buying from them for the Southern California market. At a point in time, the contractors started asking for radiation dampers to go behind their grills and registers, and Pottorff's response was, what's a radiation damper? It was something that was brand new. The California State Fire Marshal, who has always been on the forefront of life safety, had prompted UL to come up with a standard for, believe it or not, first radiation dampers. So since there was demand for them, Pottorff investigated, found out what they were, what the standard was, and decided to go ahead and test. And with successful testing is how Pottorff actually got itself into the UL products market. So it really was the start of everything, really, from a UL side point for Pottorff, was starting with the radiation dampers.
Yeah, so the quick agenda, guys. So what you see on your screen is we're going to go over. We're going to start with just an overview of radiation dampers. Kind of what are they, how they work, where you find them in the code, and why we need them, why we use them. Then we're going to have one slide about UL test requirements. So very similar to fire dampers and smoke dampers, they have their own section of test requirements that we must undergo to get a rated damper. Then we'll talk about the Fusible links, kind of how they work, and maybe some things to look out for when you're sliding on a temperature. Then we're going to talk about the two major types of radiation damper applications, that being combustible and non-combustible. We're going to probably glide over the combustible side pretty quick, but we'll spend quite a bit of time on the non-combustible ceilings, vice versa. We'll spend a lot of times on the combustible ceilings. That's mostly what you guys will see. So we'll certainly walk through that in pretty good detail. Then we'll talk through the UL ceiling assemblies and how it differs from walls, how they're very specific applications of assemblies rather than just generic walls. We'll talk about some damper sizings and damper installation methods and how these dampers interface with the ceiling. One maybe being a grill installation, one being a duct installation. So we'll talk through those. And then we're going to talk Pottorff specific models and which ones you should use where, the pros and cons to each. And then have a discussion on dynamic closure requirements, which is relatively new when it comes to radiation dampers. Fire dampers and fire smoke dampers have always had a dynamic rating behind them. That's relatively new for radiation dampers. So we'll talk through that and show you in the code where to find that. And then we're going to go through just a few product releases that we've done in the past year or so, showing Pottorff best in class and what we can do for you guys. So for starters, just a generic overview of ceiling radiation dampers, what are they for and what are they used for. They're required by building codes where ducts are going to penetrate air transfer openings in a ceiling membrane. So not the floor, but in a ceiling membrane, and not the entire floor ceiling assembly, but just the bottom. So you'll see here, what you see here in this drawing is a generic ceiling membrane floor ceiling system or flooring system. And so this inside here space is the truss base, and right here is a radiation damper. So this is a generic application of where and when you would see a radiation damper. We see these primarily in multifamily housing. Generally in multifamily housing, those floor ceilings between each of the floors are going to be rated. And anytime you're going to get in or out of those with a duct of some sort, you would need some type of protection. We'll talk to more detail about the UL side of that in a little bit. But generally the way it works, that damper it's a little butterfly damper, which is just two pieces of metal held together by a fusible link, typically set at 165. That fusible link would trip or separate. The damper blades themselves would close, and then you would actually create a fire barrier there at the penetration. So where the deck penetrates, that damper closes, and you create a thermal barrier from heat getting into that truss space. So with a fire damper, we're always worried about fire, jumping from one room to the next through a fire barrier or whatever it may be. With the radiation damper, we're worried strictly about heat. We don't want enough heat to get up into the truss space and result in some kind of self-combustion. So that's exactly what we're trying to do to protect here with radiation dampers.
Dan, just to back up a little bit, one point is that ceiling radiation dampers are not fire dampers. And the reason I say is because we get calls all the time, even our models, Cfd 15, ceiling fire damper is kind of the connotation, but these are definitely not fire dampers. They are not tested to prevent the, as Daniel said, flame spread from one zone to another. They are strictly tested to prevent heat if there was an incident in the room from radiating up through the grill or register and destroying the members above or the integrity of the ceiling above. So again, they get interchanged a lot, but ceiling dampers are definitely not fire dampers. They're tested in different methods, and we'll take a look at that here in a minute.
Yeah, well, and this slide just kind of sums up what Tom said, but there's a couple of things to note here in terms of the hour rating. So when we talk about non-combustible ceiling assemblies that we'll get into here in a second, dampers are rated up to 3 hours in that application. But just because your damper is rated up to 3 hours does not mean your total assembly is rated to 3 hours. So it's important to note when you're looking at the fire rating on these things, to look at the resistance rating of the actual assembly itself and not the damper. Just because the damper says it's 3 hours doesn't mean you can put it in a 1 hour assembly and the assembly is then 3 hours. It doesn't work that way. The assembly would still maintain the lower 1 hour rating rather than 3.
Yeah, as opposed to fire dampers, as you all know, fire dampers have either an hour and a half or a 3 hour rating. With an hour and a half fire damper, you can use it in a partition up to 2 hours. So if you have a 2 hour wall, that damper is still an hour and a half, and that's what's required by code. If you have a 3 hour wall, you would put a 3 hour damper. The damper does not take on the rating of the wall. It strictly is what it is, hour and a half or 3 hour. With the ceiling dampers, however, as Daniel just said, regardless of the rating of the individual damper, it takes on the rating of the assembly that it's installed.
Correct. As far as fire closure devices, like I said a second ago, so here's kind of a sketch of a standard everyday round run-of-the-mill radiation damper. It's butterfly blades with a spring there that would spring the dampers closed, and it's held together here by this fusible link. What you see here is it's called an LC, that's the manufacturer link, an LCB type link. Different manufacturers may use different links. We certainly use different links for different products, but for all of our radiation dampers, we'll always use an LCB type link, and it looks just like what you have up here. It's basically what it is. It's two pieces of metal that are soldered together, and you can kind of see the break there of the two pieces of metal, and they're just soldered together. And the way they work is that solder is designed to start to get a little supple at a certain temperature. And once you hit that breakover temperature, that link, that solder does get supple, and the link will separate under load. And when that link separates, the damper itself will close, and that's where you create your fire barrier.
One thing, just Just something on the fusible links. We showed on a previous slide that, at 165, the link would trip and close the damper. A couple of things about that is, one, links don't sit there and do nothing until they get to 165 and then trip. As Daniel said, the solder element starts to soften, and depending on the load, meaning the spring, the weight of the blades, etc., the damper can trip. So it can go, UL has a tolerance range on these links. So it can go, sooner than 165 depending on the load. What we normally recommend when we get a chance to talk to engineers, we normally try to tell them to put on, especially on ceiling dampers, to put 212 degree links as opposed to 165s, which are certainly allowable by the code. And 212 gives you somewhat of a margin of error. I mean, we've had instances where dampers have shipped and sat in shrink wrap on a job site and have tripped because temperature built up with a 165 degree link. The likelihood of that happening with 212 is pretty slim. Also, even when they're installed, heating is on. Like I said, you have spring load on the link. You can get some premature tripping, especially if there's vibration. These links would tend to fatigue over time. A 212 degree link would be a much better choice. So, when we get a chance to talk to engineers about it, we normally would tell them to specify a 212 degree link rather than a 165.
Yeah, 100% agree. And to that note, even during transportation, so if your job site's in the Northeast where maybe you're not so hot, well, that damper's got to, run it's going to be in a trailer from Texas or from California all the way to your job site. So it's possible that trailer on the way there could get to 120 degrees, whatever it be. Combine that to with the springs in the damper and the vibrations of the road of the truck, then you could get those closures or those failures prior to getting to the job site. So the 212 certainly a recommendation on our side. And from our side, I'm not sure other manufacturers do, but from our side, there's actually no cost delta from 165 to 212. So that's not something you'd have to worry about if you want to do that. And from an accessibility perspective, you can kind of look at this butterfly damper, and you can kind of see it may be a little difficult to get your hands up in there to replace that. It's certainly possible, do it all the time, but some guys like to have this volume control, VC options, volume control, and basically what it does is allows you to balance these dampers with that volume control, but it also allows the link is actually placed on the bottom here. So you remove that grill and you have direct access to that fusible link rather than having to reach up around the blade. So it makes it a little easier from a replacement or a testing perspective.
Yeah, something to be aware of. It's hard to tell in that photo, but that volume control device does hang down a bit below the damper. So if you're using a grill that insets, you have to be careful that you're going to have enough room so that it doesn't interfere. Also, a grill that has an OBD on it, that use one of these, you would do your adjustment through the OBD. But in the cases where you can't do that, then this would be an option to be able to give you some kind of balancing control for the damper.
Right. So this slide is discusses UL 555C. So the way UL breaks their testing up, they have UL 555, which is the testing that fire dampers must undergo to achieve their rating. Then you have UL 555S, and that's just for the smoke damper side, the smoke protection. And then you have UL 55C, which is the testing that radiation dampers must undergo to get their rating. So there's 5 major tests. Of those 5, there's one that's I guess really major and more difficult to pass, and it's the fire endurance test. And basically, we're doing that fire endurance test. We're installing a damper in a full truss assembly, and then we're putting that truss assembly under fire load or some kind of prescribed fire situation, and we want to see how that damper is going to react. And ultimately, what we're looking for those blades to close, and then we're looking for, over the course of an hour or whatever the predetermined time is, we're looking to make sure that there's not too much heat transfer from load up above to get up above the damper into the truss base. So that's the most difficult test for us to pass. But we also have these other ones we have to pass also. Salt spray test, What we're trying to do there is, or what UL's trying to do is mimic what these dampers are going to see over the course of their lifetime. So we have a salt spray test to simulate that dust, and then the damper's got to operate after it undergoes that spray test for 5 days.
Yeah, and that's to simulate, years of sitting in the duct open, hopefully open, because that means it's never tripped, and it accumulates any kind of dust or particles, I'll say gunk up the spring, potentially closure spring. So the idea here is to mimic that, so that even if a damper has been installed for quite a while, if it does see an elevated temperature, that the link's going to still trip and the damper blaze is still going to close.
Yep, and the next one is the closing force test, and this one's pretty simple. It just wants to make sure that we have 2.5 times force needed to close that damper. That spring is strong enough. It gives us a little bit of leeway. So we want 2.5 times the force needed to actually close the damper from our spring. And then a closing reliability test. That's just to make sure that over time, if these things are going to open and close, especially using maybe a volume control, or they may be open and close quite often, to make sure that they are going to operate without any signs of damage after being cycled 250 times.
Yeah, and this is obviously because they're not motorized. This is just a manual cycle. Blades are held open, let go against the spring. And the idea here is to test the construction of the damper to ensure that repeatability and that it is going to close and function as designed. So, it's only designed really in a heat situation to close once. So UL does a 250 cycle test to make sure that, rivets, pins, anything, toggle locks stay intact.
Okay, so now getting into 2 different types of sealing types that we're going to talk about. One is a called suspended grid or non-combustible, kind of used either way. And that's just a sealing membrane that's held in place generally by a wire-supported metal grid. So typically when you see like a lay-in ceiling, those typically are not rated any longer, but in some cases they would be, and that's where you would have that. So you would have, a 2x2 lay-in ceiling. You'd have a 2x2 step-down grill probably. And on the back side of that grill, the neck of that grill, that's where you'd put this radiation damper in that kind of applications.
Yeah, and just to, what you saw, the test requirements you saw on the previous slide, when you test to those parameters, and if you're successful, what you get actually is a rating on your damper that is only for these non-combustible ceilings. Okay, lay-in ceilings, they used to be popular one time. You had a lay-in diffuser with a blanket on the back and a damper on the neck. That is the approval that you got. When you get into the combustible assemblies, and we'll talk about this in a second here, is that you have to test individually into every one of those assemblies to get approval for them. So it's kind of two different ratings, but the basic UL test just gives you the non-combustible rating.
Yeah, and on the combustible side, there's 3 separate types that UL kind of breaks it down into. We're going to talk in detail about a couple of these. The first one is there'll be no damper allowed. So there'll actually be a UL assembly, and UL or however it's tested was not tested with a duct penetration. Therefore, you're not allowed to penetrate it. And I'll show you an example of that here in 1 second. Another one is a generic hinge type damper, so something that can actually be fabbed in the field, or a generic any radiation damper that, as long as you meet certain parameters, could be installed there. And then the third type, and by far away the most common type, is where a specific damper is required, and that's what Tom was just alluding to. A perfect example is what you see here is an L521 or a P522. That L just stands for floor ceiling designs, while the P stands for a roof ceiling design. But in any case, a specific damper, when you have that number like that, we're going to go in and show you how to do this, but you can look and see exactly which damper would be required in the application. We'll get to that one here in just 1 second. Just the one last slide on the non-combustible, just kind of wanted to show you guys some of the generic dampers. And that's what you would see here: a butterfly type damper, a curtain style type damper, and then a low profile. So a curtain style that's very similar to what you would have with a fire damper. The only difference is on the fire damper, that blade stack is actually metal. Here, it's actually a fabric blade stack. It's like a cable fire blanket type of stack that will close.
Yeah, and that's not a type that you guys engineers would normally specify or you guys would use. But where they are used, the advantage, because you don't have a butterfly, so as you know, on a butterfly, the larger the size, the bigger the blades get, the more intrusion into the space. With the curtain type, it's one height regardless of what size the opening or the damper is. And so where they're used primarily is with bathroom fans, because you can't have blades sticking up in the bathroom fans, and you have to have a constant height. These dampers are used, and we OEM these type to most of the major fan manufacturers, Panasonic, Brone, Delta Breeze, those type. They use these products. As a rep, quoting jobs, you would very rarely see an engineer quoting specifying this type of damper.
Yeah. So get into the combustible style dampers, and this is by far and away, again, the most common that you'll see. And this is what you're going to see in any kind of multifamily wood stud type of housing. So wood truss, wood stud, however you want to call it. Typically have a fire rating up to 1 hour, and they have design designations. And that's what I started to talk about a second ago with the L's and the P's. And if you guys were to call me or call Tom or call our customer service, you're going to say, hey, what kind of radiation damper do I need? The first question we're going to ask you, okay, well, what's your assembly number, UL assembly number? Not most of the times it'll be found either on the mechanical plans or maybe even in the architectural drawings, in the details. But there should be some type of designation that you can provide us. If you can provide us that number, we actually find it very easily. And I'm actually going to go on right now. I'm going to exit the presentation and I'm going to go onto UL's website and show you guys how to find that and see the different tabs. So we talked about the three. One is where no damper is allowed. One is where a specific damper is only allowed, and then one where you may have a rare case where a generic damper would be allowed. So I'm going to exit the presentation really quick, and I'm going to walk through each of those. So what I generally do is not even go to UL's website. It's easier just to type in the UL assembly number from Google. So the first one I'm going to start with is actually a Pottorff design. So I'm going to start with UL 521. I'm sorry, UL 521. And then you'll see it's going to be the first UL option. It's usually the second one. USG is often the first one. You click on this one, L521. You might have to create an account with UL. I certainly have one, but it's free and it's quick and easy. So don't worry about having to pay for it. And so what you have here, you have this assembly that basically tells you exactly how to build this entire assembly. It tells you the truss spaces or the truss distances, the heights, the type of wood, type of chipboard, everything you would need to build this assembly you have right here. You can kind of see a drawing of it here, and then you kind of go on the details and you'll see what kind of subfloor, what kind of vapor barrier. So it tells the contractor exactly how to build and what materials to use. Now, in terms of damper, you can go through here and you can read all of it. The easiest thing to do, because there's a lot of information here, is just to do a control find up at the top. It'll open up and just type in damper. And then it's going to bring you down here to show you which dampers are allowed. And you see sitting radiation damper, and then it talks about the maximum requirements, so what the depth is, how large it can be, and all that fun stuff. But more importantly, it tells you the model damper that is allowed, and then the alternate if there's an alternate allowed. So you'll see Pottorff, we actually own this listing. So all Pottorff companies, CNS, that's one of our sister companies, Pottorff, CFD 521, Pottorff, CFD 521 BT, and so on and so forth. And you'll see all the Pottorff models, but you won't see any of our competitors. And then you'll see where you'll see Delta. Like Tom said a second ago, we OEM for the top three, Delta, Broan, and Panasonic. And so you'll see Delta models, Panasonic models, and Broan. But you won't see any of the competitor. And so that's why it's very important to make sure that you look into this to make sure that you're getting the right damper. And it's not always going to be ULP 521 like I put in here. It could be all sorts of numbers, but the same scenario, you just go in here and you would go into Google, type in the assembly number, and it would pop up what you're looking for.
Yeah, just a point of note with these assemblies is that Pottorff or any damper manufacturer does not go to UL and say, I want to test an assembly. Like, for example, this L521, USG, United States Gypsum, ran the test so they could get their drywall approved, for this assembly. As a damper manufacturer, we were asked to participate in the test. So we really just become one small piece of this overall assembly. And because the test was successful, that's why our product is named in there. Now, there are some that are generic, as Daniel said, that UL will allow multiple manufacturers in there. And there's some that are proprietary, like, for example, 521 here. There also actually are some proprietary to other manufacturers. So you do need to take a look at that design or know what that design is when you're quoting a product to make sure that you're okay.
Yep, and so I'm going to quickly Google another one. UL is one I found it before we came on here, L003. And again, the same one, so the first UL option. Then you click on it and you see the picture. First of all, there is no damper. That's not always a telltale sign, but it's pretty close. The telltale sign is if you do a control find and you don't find the word damper in there, that means that this assembly does not allow for any duct penetrations with dampers allowed behind it. So in this case, if you were to come across this, you need to reach out to the inspector, to the engineer, whoever it may be, and figure out an alternative course of action, because they either need to change assemblies, which would be kind of hard in the middle of a project, or more likely they would just allow for some kind of deviation and allow you guys to use a rated radiation damper. So certainly bring it to their attention though, because it's if not, you may get caught by the inspector and then maybe too late after that.
Yeah, this is actually something that we get quite a bit of questions on. We get the design number, we look it up, and there's no penetrations. So the two choices are, one, there are usually, with most of these designs, a similar penetration that allows openings. So it would be up to the engineer or architect to find that assembly and change it on the drawings. Or if they don't do that and you already have penetrations, then it would be up to the local authority to allow you to put those in.
Right. As far as styles goes, so jumping back into the presentation, there's a few different styles. I'm not going to go in detail here. We're going to go in detail into the Pottorff specific options here in a few minutes. But you have a sheet metal plenum, which is just our base 521. That was the first from a Pottorff perspective. And then from there, we kind of grew to create a CFD 521 IP, which is an insulated plenum, a CFD NP, which is no plenum, where a plenum is built in the field. CFD 521 ST, which is for a steel truss, and then the boots, a CFD 521 BT for a boot, and a CFD 521 for a 90. So you can just kind of see the nomenclature there. CFD 521 is very, very well known in the industry, so we try to leverage that and just kind of continue, the IP, NP, and so on and so forth at the end of the line. As far as installation, and more important than installation is the sealing interface. So for installation, obviously we recommend go and look at either our installation instructions or the manufactured installation instructions that you're using. But even just as maybe more important is how these dampers interface with the ceiling. So all these dampers are going to come with what we call a plaster ground, and that's basically the depth of the angle that the lip of the bottom of the damper would actually protrude through. So by default, we have a 5/8 inch plaster ground. We also have an optional 1 1/4, and then 2 or 4. So you'd use a 5/8 if you have a single layer of sheetrock, which is relatively rare. If you got 2 layers of sheetrock, you would order it with an 1 1/4 inch plaster ground, and that's available and selectable in specs in the pricing software.
Yeah,
then you also have. Go ahead.
I would say, just in general, the whole idea, the whole intent here of the installation is that, you know, you have your damper in the opening, your damper box, I should say, in the opening. This plaster ground or flange sits on the back side of the drywall or top side of the drywall. Then you have the drywall, and when you put your grill on, now you're going to screw through your grill through the drywall into this flange to create a sandwich that's going to hold this damper in place if there's an incident and protect the opening.
Correct, and that sandwich is
some situations like you see on the right hand where it says end view duct to duct connection. That would be for when you're going to go down to the air handling unit, say in a closet where the duct's coming up from there and penetrating. There obviously would be no grill. So you could order the damper with a deeper plaster ground, 2 inch or 4 inch, so that you have something coming down through the ceiling to connect your duct to. And in that case, you would put an angle underneath on that duct. So again, to take the place of the grill, so you're creating, again, a sandwich to hold the assembly in place.
Correct. And when you get to this type of scenario, which you would see here, a lot of times the application is such that down below here, there's an air handler, and then you're ducting up into the truss space. And then from there, you're going to branch out with multiple ducts, whatever it may be. And so people want to use this many times what is an insulated plenum. They want to use it as an actual plenum and have multiple ducts coming off of it rather than just one. And so we do have multiple taps allowed. Only deal is when multiple taps are allowed, or when you use multiple taps, there's a requirement the blades have to close a little bit closer to the sheetrock. So you see here an 1/8 of an inch. We want to be an 1/8 of an inch above the sheetrock, which is typically not that big of a deal because you're not worried about anything underneath here. It's all just basically void space, the duct. Now, if you were in this application where you're above a grill, you're typically 9 times out of 10 only going to need a single duct because you're using it as a supply coming into that duct, and it's going to come down and supply from here. And a lot of times, like Tom said earlier, this grill may be you may need an OBD or something like that, so you need more space. So when you have a single tap coming out that damper, we actually allow for 3.5 inch setbacks. So it gives you 3.5 inches above the sheetrock, which gives you plenty of room for pretty much any OBD that you guys be using. So getting back into what do you do when you come across an application where you have a UL assembly number, but you don't have a Pottorff damper that would fit that assembly number. So maybe the assembly number doesn't allow for penetration or whatever it may be. What can you do? And the first answer would be you talk to the inspector, talk to the engineer. The second answer would be with local approval, you can use a Warnock-Hersey installation. So you have a UL installation, which is what we talked about up until now, and then there's a secondary competing, I'll say, Intertech agency that allows for a Warnock-Hersey installation. And it's just a little more generic. It's very similar to a fire damper. It doesn't get into the specific assemblies as much as what UL does. And so a lot of times you can substitute a Warnock-Hersey installation method with UL. Ideally, you'd want to use the UL, but when that doesn't allow, certainly look at using the Warnock-Hersey installation. Yeah,
and if you could imagine the scenario, you know, the UL fire resistance directory has, you know, hundreds of designs, and no manufacturer can be in all of them. In fact, most manufacturers in a large handful of them. So what happens when you have a design where there's one manufacturer but there's competing products? And that's where Warnock-Hersey came in. You know, as Daniel said, they're an alternate testing agency, and they have given, I'll call it a generic or an overall wood truss installation to help cover those situations. so it's not always proprietary. If you take a look at Ruskin or Green Hex or Naylor's damper sheet, their installation sheets, you will see a Warnock-Hersey listing on theirs that looks exactly like this. Everyone has the same one, and the whole purpose was it to help not create a proprietary situation. Or if you need a damper that, for example, Naylor's approved and no one else, but you're quoting the job, as long as in that municipality, Warnock-Hersey is an acceptable installation, you can use this damper. For example, in most municipalities in Florida, they recognize and accept the Warnock-Hersey installation, so there's no issue with doing that there. You would have to check your own particular, state or territory to see if it's accepted.
Yeah, and to that point, there was actually a question, Tom, and the question was, are there UL listings for radiation dampers that Pottorff does not make a product? I think you just answered that. The answer is we're going to have the product. Now, whether or not we had that specific listing, we can't guarantee that Pottorff would have that listing because they are proprietary to certain manufacturers. I would say that Pottorff certainly has by far and away the most proprietary listings, but we do certainly want all of them. So when you get in that position, this is what we recommend is either talk to the inspector, talk to an engineer, or use a Warnock-Hersey installation. So those would be the two options, Bob, that you would have if you got into a situation where Pottorff didn't have that assembly number. So this just kind of reiterates for the folks that may not have been able to, if we send this out for the folks that didn't see the UL website, this just kind of talks through those three main categories one more time. So again, this is, if there are no dampers allowed, you can see this is just a truss base here, and there's no penetration whatsoever. The next one's going to be if you had just a generic, either a generic radiation damper or even just like a hinge style door that's actually fabbed in the field. Very, very uncommon, but UL certainly allows for it in very few applications. And then the third one, like I said, we beat this one to death, where you have very specific proprietary type of UL designs where you need to use a specific damper. And that's what you see here. So a little redundancy there. Want to make sure you guys saw that. As far as transitions, we're going to start getting into some of the product specific and product options here. So what you see here are some of the transitions. 9 times out of 10, what you're going to have is just a round transition on one side or multiple sides. But you can also have the oval. If you're going to go through the oval, we just need to know the width and the height, and we can certainly fab the oval. Same thing with the rectangular. Give us the dimensions, and we can put that that transition in pretty much any side of the damper as long as the size permits. Our standard size for the collar is 2 inches deep, but we can go beyond that to 3 inches deep collar if you really needed it, but 2 inches is pretty straightforward. So now getting into some of the Pottorff specific dampers and kind of the pros and cons of each and when and where not to use them. So just a baseline CFD 15, this is what you would see a lot of times in the non-combustible type of ceiling. So in like a 2x2 lay-in that we talked about, where you go in the back of a grill, this is where you would see that many, many times. You also see, if you look close, you'll see actually there's some blade insulation on the black side of those blades. What that does for us when those blades close, it just gives us a little bit more insulation to create that thermal barrier to pass that fire test. So you won't see this on all of them. Some of the dampers, I forget the cutoff exactly, maybe you know, but with the damper small enough, we don't need that extra cable. We don't need the extra insulation. But when you get into some of the larger sizes, we need that extra protection. So we'll put that blanket on the back there.
Yeah, every manufacturer does it differently on these. Again, the insulation on the blades is to stop the heat from radiating through up to the members above. So it really just depends on how you can pass the test. Some manufacturers put insulation on all sizes. We put it on 12 over 12 by 12. Anything under 12 by 12 would just be the bare blades. Just the metal, because we've proven that that's just the blades in those small sizes still can prevent the minimum amount of heat from going through. It does just depend on manufacturers. You don't order it. You don't have to pick it. It's size dependent, so it's automatically manufactured that way depending on what size you order.
Yep, and then we have CFD 15R. That's just a run-of-the-mill round radiation damper. It's a round version of the CFD 15. We typically see a lot of these in fresh air intake coming into maybe an equipment room or an air handling room or something like that. That's where we'd see a lot of these. CFD 15SB, that's just another type of CFD 15. What we do, instead of using a butterfly blade, we use a single blade. So what it allows you to do is cut down a pressure drop. It's relatively uncommon to see these because butterfly blades don't have much pressure drop anyway, as long as it taps in right. But the idea behind this is you have one single blade rather than the butterfly blade, and it does take a little bit of the pressure drop, reduce a little bit of the pressure drop. And then the CFD 521, so this is probably the first wood truss radiation damper that we came out with. And what it is, it's a sheet metal box over a CFD 15, simply put. It's tested a little differently, but ultimately that's basically what the damper is. We don't see this used very often. I would actually caution you guys from using this one unless you absolutely need it. If you're able to use the CFD 521 IP, the IP is a lot more cost competitive. But the CFD 521 is great specifically for nursing homes where code's not going to allow you to have any kind of fibers in the airstream like a fiberglass. That's where you would use this. It's just a sheet metal box, and then they would come in after the fact and insulate the exterior of the box. So for nursing homes, it's certainly great to keep those fibers out of the airstream while getting the same fire protections you would get from any other radiation damper. The CFD 521BT, that's the boot. This is a plug and play. Basically, any residential boot that you would see, that's exactly what this is. The inside of it is insulated, so you do get that R rating, but you do get those fibers in the airstream. So typically, you'd see this is you would snap boot rails on either side, put this thing up into the truss space, and basically walk away. It's that easy to install these little BTs. And then the CFD 521 IPs and CFD 521 STs, these are the same thing, just installed a little bit differently. But essentially what they are a CFD 521 with an insulated box, insulated plenum rather, instead of having a sheet metal box. So these are much more cost efficient, much more easier to install, much more easy to cut the taps in the field. So for those reasons, we see these much more often than the CFD 521s. This would probably be what you'd want to use, I would say.
Yeah, just a couple points of differentiation on the standard CFD 521, the metal box. You're always going to order that with whatever tap you need. It would be kind of difficult cutting taps in the field for that, on those. The downside to that is that you put the tap on a particular side, they get it in the field. The way the truss runs is opposite. So now it's interfering and you have the tap on the wrong side. On the IP, which is the fiberglass box, most of what we sell are without tap. And the reason for that is it gives the contractor the flexibility to cut a tap in on any side that he needs to fit the field conditions. And also, especially if you're using these over a unit where you're going to have multiple taps, you can even come out the top. And it's much easier to cut in. So just be aware of that. The other thing is that we've had cases where contractors have gotten caught with the fact that your particular state has an energy code. The metal box is not insulated, so they have to go back and wrap those boxes. Gets pretty expensive. If you're buying the fiberglass box, it comes in R6 and it's available in R8, so it's already insulated. It meets most states' energy codes. And it is actually a less expensive product. So you kind of get the best of both worlds when you're using the IP.
And then you get the CFD 521 NP, and this NP just stands for no plenum, but it's exactly the same thing as the IP. The only difference is the guys are going to build the plenums in the field. That's just a preference thing. Some guys want to order the assembly 100% from the factory. Some guys want to order just a damper and build their own box. And of course, we do have installation instructions showing exactly how to build that that insulated film on top of that box and install it. So that's just a preference to the contractor.
Yeah, just a side note on that. That says, field mounted insulated ductboard box. We actually also now have approval for a steel box. I don't know why anyone would want to do that, but you can use a steel, buy the damper and put your own steel box on it also.
And then the last one, and one of the most recent additions to the CFD 521 family is the CFD 521-90. So this is the exact same thing as the CFD 521 BT. The only difference here, the two major differences is one, obviously, the tap comes out the side. So if you don't have space a lot of times, depending on the size of your damper duct and truss base, you may not have time to get your duct to go all the way around to the top of that damper. In this case, you actually penetrate the side. The downside of this one is the damper itself is not insulated. So where the BT is insulated, this damper is not insulated, but it does allow you to come out the side for areas where maybe you're constrained by space. And then the CFD 20, Tom talked about this one earlier. We see this one, over bathroom exhaust or something like that. It would pretty much be the only time you'd see this. Outside of that, you wouldn't want to use this anywhere else. But that's certainly what it's there and used for at CFD 20.
One word of caution with these for those of you who sell bathroom fans or rep their various ones. The one thing you cannot do is buy this damper and marry it to, say, a Panasonic fan and have a UL rating. The dampers that we make for those manufacturers actually are a bit custom to fit the fan housing and is tested that way with the fan housing. So you could not, as I said, previously here, you could not just buy this damper and marry it with a fan. You would have to get the damper from the OEM or the fan manufacturer along with the fan for it to maintain its UL rating assembly.
So the last radiation damper slide we've got is dynamic closure requirements, and this is very important because it's relatively new. I think it was 2015 of the International Building Code that it was actually adopted into the code. And it wasn't until I would say maybe a year and a half, 2 years ago, we actually started to get questions about it. But you'll see this on the right-hand side here. This is actually a cut and paste from the code, and it says only fire dampers and ceiling radiation dampers labeled for use in dynamic systems shall be installed in heating, ventilation, and air conditioning systems designed to operate when the fans are on. So 9 times out of 10, in these specific assemblies, especially the UL assemblies, the fans are not designed to operate in the fire. So they're going to be tied to maybe a smoke detection system or whatever it is, so that in the course of a life safety event, these fans do shut down. But in some cases, you will have what code is calling dynamic closure for a radiation damper.
Yeah, let me back up a bit and give you some of the history behind this. Just like 20 years ago when fire dampers were static only, and then they came out with a dynamic test standard. The same thing has happened with radiation dampers. Now, the advent of this was from the fact that you have your unit in the closet and you're going to be blowing air up into the space and to the outlets. Now, previously there was nothing that would guarantee that those dampers would close if the air handler stayed on in an incident. And there was no such thing as a dynamic damper or test point in the UL standard. So what's happened and been happening is they put a thermal cutoff on the unit. So when there's an elevated temperature, the unit cuts off. So now your damper is going to close against, a shut-off unit. No problem with the damper. That's the way it was tested. Okay. Several years ago, it's expensive to put a thermal cutoff in, so people would rather have a damper that could close against the flow. So UL was petitioned to come up with this part of the standard. So UL did, and it was a number of years ago. It was added into the standard, but no one tested to it. Okay, and the reason that no one tested to it is UL made the test pretty tough to pass because, as with previous, you test your damper in the assembly, and if your damper maintains the integrity, you get a passing rating on the damper. Well, with the dynamic part of the UL standard, the whole sealing assembly has to be tested dynamically. So one, you're looking at a very expensive proposition, and two, as damper manufacturers, you're looking at the possibility of the assembly failing somewhere, even though the damper performed, and still not get the rating. So because of that, none of the major manufacturers test it to the dynamic standard. Now, IBC, because it was available, as you see here on your right highlighted, they put it into the standard in the 2015 edition. And when this was put in, there was no product available. And we would get questions all the time. Hey, I need, the engineer, saw this in the standard, so he put it in his spec that he wants times. Well, there was no product. Okay. Recently, one manufacturer, a small manufacturer, passed with one of the assemblies. So now they have that rating. But what does that really mean? All the sealing ratings that we talked about previously and the ones that we show on our catalog sheets like L521, P522, and so forth, none of those are dynamic assemblies. So therefore, no dynamic dampers are available for them. So unless you're using this one obscure assembly, and which no one knows what it is yet even, dynamic rated sealing dampers are just not required, nor are they available. Now, since someone did come out with it, we are reassessing the situation and going back to UL to see what we could possibly do, but there's no way we could go back and test all those assemblies dynamically, and neither would any of the other manufacturers. So we kind of think this thing's just going to die on the vine. So again, there's no assemblies that can take a dynamic closure rated product except one, and none of the common ones are dynamic rated. You cannot interchange them. So you can't use what I'll call the current static damper in a dynamic assembly or a dynamic damper in a static assembly. So again, it's caused a lot of confusion. We get the questions all the time. I need a dynamic rated damper, but they just not are available at this time.
Yep, and so we are just a few minutes away, so I'm going to jump ahead to one of our latest releases, guys, and this is, if you guys have used List, which is by far and away the best louver and information selection tool on the market. It's been available on our website for quite some time. When we first launched it, we required users to log in and create a user account and all that fun stuff. Now you can go on there, it's free to use. No login, no registration required, so you can go one and done, really quick, fully responsive. It allows you, obviously, to do louver selections, but more importantly, we just launched List available on an app. So for Apple iPhone or for Android, it's certainly available. And I'd recommend that each of you guys go download it. The way that Apple works, the more downloads we get, the more available it'll be, or I guess easily found, easily searchable. So please go in and search Pottorff List, download it, rate it. We'd certainly appreciate it. And one more time, just to reiterate, we have one more webinar coming up the week of November 17th. It's for constant volume regulators and industrial dampers by James Carlin. Certainly tune in for that. It's got a lot of information for you. As far as this presentation, we do have, I did have one question that I got a text message on. It was surrounding, can Pottorff provide Brone or Panasonic or Delta dampers or fans? The answer is no. We have obviously agreements with each of those that we're not able to do that. We provide to them strictly on an OEM basis. So that would be a non-starter for certain.
Yeah, and some of the reason besides the contractual part of that is that, like I said, these are special, kind of specially custom made to the fans. And when we set up and run them for the manufacturers, they're buying several hundred, if not more at a time. We do not maintain any stock of them. So if somebody needed 2 or 3 of them, we couldn't possibly set up to run them anyway.
And I had one more question, and it has to do with a drawing that we showed early on asking about the rate assembly versus a fire damper installation. So I'm going to go back there and try to find that. While I'm doing that, if anybody else has any other questions, feel free to type into the chat box or take yourself off mute and ask questions. We can certainly go through those, but I'm going to run back here and try to find this slide that John was referencing. It's the one that says rate assembly versus fire damper. See if I can't find the rate assembly drawing.
I'm sorry, Daniel, I didn't hear the question.
The question was, can you go back and explain the drawing on the right, rated assembly versus fire damper installation? So I'm not seeing the drawing, but what I'll say is, if you're comparing a fire damper installation to any of these rated assemblies that we went through, they're 2 completely different beasts. So fire dampers are not allowed to be installed in any of the assemblies that we've talked about today. Fire dampers cannot be installed in anything except for a concrete or masonry partition when installed in the horizontal position, except for very, 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 very few limited cases.
Yeah, where you're putting these dampers in horizontally, there are no fire dampers approved for combustible assemblies. There is one particular one that's for top of a shaft or bottom of a shaft, but in general, you would, in any of these floor penetrations or ceiling penetrations, you would put a fire damper. They're not approved for it.
Exactly. Yeah, guys, and that's all the questions we had, but Tom and I will stay on for a little bit longer. If anybody wants to hang around, you can certainly ask more questions or have a Q&A, so we'll hang on for just a few more minutes. But thanks again for your time. We certainly appreciate it.
It was, I think, a question just popped up about the
constant flow regulator.
Yes, with dampers.
Okay, so question. Also, I get a lot of jobs looking for a constant flow regulator with CRD. Is this something you guys are looking into? I'll tell you what I've done personally on case-by-case jobs. I've done a CFD 531, so the sheet metal box, and thrown a radiation damper into, or thrown a constant volume damper into the neck of the diffuser up above the truss base. So I don't know from adding it to a product line for a specific damper model, but it's certainly something we can certainly do, I'd say on a one-off, at least in the interim. I certainly have.
So you could do it like loose?
I've actually done it both. I've done it loose so that they can put them on the field, and I've actually shipped them from the factory with them installed.
Okay.
Hopefully the other one that we see, the sliding body one.
Right. We have in the Boston market, we have quite a few installations with a curtain fire damper in a box with a
almost like a type
B. A CRV, and it needs to be removable from inside the box for future whatever. Is that something that you can come up with?
Removable? You mean the car removable?
Yeah, correct.
Yeah. So John, you're talking about the having a thin line damper or whatever in the box with a flange for the grill, with a grill, and then the
exactly.
Right?
Yeah, you see them in a lot of hotels and apartments.
Right, and normally they're put in. You know what? We'll have to have James take a look at that because I think right now you're putting it in from the outside, so to speak. So once the duct goes on and you go through the grill, you probably would not be able to get that out of there. We'll have to have James take a look at that.
Okay.
Product manager.
Also, the one question that I had was trying to find that detail. It had the air handler installation going through like in a closet and then going through the ceiling.
Right.
Right there.
Yeah.
That's the one.
Okay.
So if it's going through the ceiling, what's the difference between a fire damper and added installation and a CFD?
So in this position, you wouldn't be able to install a fire damper. This is a wood stud, wood truss application, and fire dampers cannot be installed horizontally in a wood stud application like this. And that's the reason. That's where radiation dampers come from. That's why we have them. So
is that assembly that we're looking at? Is that like a 521 rated assembly, or is it just a?
Yes.
this particular one is yes.
Yeah.
So what you
So
have,
that's-
so these two drawings, John, are identical. The only difference is one, you have a duct penetrating all the way down. One, you have a grill. But on this side, you're using a set of angles around the perimeter of the bottom side to take the place of the grill. So they're essentially the exact same installation.
Okay, understood.
Yeah, I know it's pretty common that they slap a fire damper, horizontal fire damper in there, but
Right.
And it's just not Pottorff, it's all the manufacturers. There are no fire dampers for horizontal mount in a combustible assembly, except for one. There's one called an I-503, which is shaft, and it can be a dedicated shaft, and the damper can be put in the top or the bottom of that shaft. If you go online and look at any of our actual fire dampers, or you look under the instructions, you'll see I-503. You can take a look at that, but that is not this. That is just strictly one specific installation.
So the limiting detail here is that it's a combustible assembly.
Correct.
Right. Okay.
Good questions. Thanks, guys.